Last video was about taking the data from within R, the datasets that are available within the packages. But in this video, we will go over the process of adding the data into the Rstudio through the file within desktop. It is not rather data from an internet. And how do we do this? How do we access the variables within the data set? These things are starting point for the analysis of data sets in any package, and R is not an exception. So what is the data, and where did I take this data from? The data is from this website. I barely searched in Google for the data for multiple linear regression, and it didn't take much to find this data. This website, it's a good website. There are lots of data for regression. For example, for linear regression, there are lots of data as well. And I took multiple linear regression datasets, and out of them I will be looking into the health datasets. There are 5 variables, and these variables are about the death rate of that accounts for the per 1,000 residents. In this dataset, there are a number of doctors, hospital availability, income, density, variables within the datasets. And the dataset is in the form of Excel file. It could have been a CSV file, comma separated file. It could have been other types, but the most important thing is how to use and get to the data, get to the variables, and how to understand the relation between these variables. And now that we turn to the Rstudio, there are some codes, and I will execute these codes. So for downloading the dataset, we need to attach the library, which is read Excel library. The data is located at documents folder, within documents folder, and I attach the data. Also I want to import it into the Rstudio, so I denote it with the name and equality sign. It means we equate this, the right side to the left side of the equation. So let's run this line. So we have here 2 things: the value for the data, and the data itself, which has 53 observations and 5 variables. And of course it's interesting to find out if there is a relation between death rate and doctor, hospital availabilities, income, and density rates per mile. Let's go over. Of course, the names does not tell anything. They are denoted x1, x2, x3, and the names are death per death rate, doctor, hospital rate, and when we look for the names, of course we will see only x1, x2, x3. This doesn't tell anything. As I told, it's from the dataset website, and there is explanation of the names of the variables. Of course, it is possible to rename these variables, and or it is possible to make some codes for these variables. For example, to equate x1 to the death rate per 1,000 residents, or make a dictionary. This is also possible in R. But for now, we will go over these with the simple values. So we have 5 variables. The summary data type. Summary says not very much, but still it's a summary. There are minimum, maximum values, quartiles, and means. So let's see the data, and for this we may call the fix function. Here it's also possible to change the values, but I'm not gonna do that because I want to see the effect of the. For example, I write 1 here and that's it. You can also change it. Okay, let's write some number, because for example 7 to 100 availability 409 and 96. So we have added a row to the data set. It's possible, and we quit this. It is not going to change a lot in the regression because it's only one data point. So let's do the regression and see if there is a relation between the death rate and availability of doctors, density, actually the variables are hospitals, availability, income, and other variables. So we have run the regression, and let's see the summary. So now let's make it bigger so that we see in one place everything. And so our formula is like this. So this is the death rate, doctor, hospital, and these things. These are the variables, and the aim is to see the effect of the variables into the investigated variable. So we look at the coefficients list, coefficients object of the list. Summary, as you know, shows some objects within the list. It's a named list, and we look at the coefficients object, the intercept. So the starting point? Does it start from 0, or it, even if there is no doctor, even if there is no income or hospitals available, will there be some death? The logic tells that yes, because death rate is unavoidable phenomenon. People come to life and go out of life. There is no other reason needed for this. Their life decides this, and it doesn't depend on anything. So there is some value, t value, it's more than 2, and so it's significant, and it's 3.25 to the e to the power of 0.7 minus 0.7, though it's a very low number. It is significant even at the 1% level. And what about the second variable, doctor availability? Actually, it seems that it's less than 2, the t value, so it's insignificant. It's insignificant even at 25% level. So the regression, merely the regression shows that given the numbers, it's insignificant, the number of doctors. So let's look at the hospital, third variable. The hospital availability is even insignificant, more insignificant than doctors availability. And so the regression says that the relationship between doctor and hospital availability is insignificant at let's take the common, even at 28% on significance levels. So let's pass on to the third variable, income per capita. Income per capita, it's less insignificant, but still it's insignificant even at the 10% level confidence level. So also it's less than 2, the t value. What about the last variable? It's population density per square mile. It's significant at 10% level. The value is 1% higher than 5%, so it's something like 6%. It's significant at 10% confidence interval. So the if we only look at the coefficients, we come to the result that there is a starting point, there's an intercept, and the last one, density per square mile, is significant. The intercept is significant even at 1%. The other is significant at 10% significance level. And let's look at the F statistic, which is about the whole regression. Is there any good fit of the overall regression? Did we have a good regression estimates? And we look at the F statistic, it's 1.9, and for the 9 degrees of freedom, p-value is 11%, so it's at 10% level is insignificant. Also the R square is adjusted R square, which is the most important one. It's 6%. So all the variables explain only the 6 or 7% of the death rate within the country. You may agree with me that it's not a good power of regression. So these regressions needs to be enhanced. More data, more variables can be added to the equation to decrease the residuals. Yes. In this video, we went over the procedure of adding a document which is already in our computer to the Rstudio, looked at some statistics and looked at the data sets, the summary, learned how to go over and how to change the values. Also, we made our regression. With four independent variables, IVs, and looked at the summary. How we learned how to access the variable within the data frame. So we use a $sign to access the data within the data frame. I hope this was an interesting video about Rstudio and starting to do analysis within the program.